is day 1 of Algebra 2, and every single day I will begin by titling my page as close to exactly the same as this. So I like to write Algebra 2. And this is Unit 1 because we're just starting. Unit 1. And because today is the first day, we write day 1 notes. And then just to help myself stay organized, I like to number my pages in case I tear these out later. This is page 1, so I'll write that at the corner. And today is Monday, October 6th. So I will write that over to the side here. Monday, October 6th. So I've got my page titled. I'll let everybody get your own title on your page. It's really good to make sure that you have some sort of way to organize your notes so that when you're flipping through your pages, you know what you're looking at. It makes it a lot easier to tell what you're looking for when it's titled. You can find it easier. And did I start? Yeah, I did. Okay. So the very last thing you may have learned, if you're coming from Algebra 1, I believe, is systems of equations. Am I correct in saying that?
Yeah, I think so.
Okay, so some of you are not coming straight from Algebra 1. Some of you may not have been in a math class in years and years and years and years. So what I like to do is not assume that you're coming from what comes right before this. I like to give us all a review of the basics that we're going to need to ensure that we can get up to this level. So what I'm going to show you and what I'm going to have you write down first may feel silly and a little bit below the level we should be at, but I promise there is purpose for that. So what I want us to start with is I'm going to put kind of a subtitle here, and we're going to talk today about the basics of solving equations. Just a simple equation. Basics of solving equations. So whenever we are solving an equation, we're going to have a few things. We have a variable, the letter, and we're going to have an equal sign. We're trying to solve for the number that makes that equation true. What'd you say? Get a folder? Yeah, go ahead. Go ahead.
Thank you.
You're welcome. One of the first things that we need to review in our basics is our operations. So operations are the things we do to numbers. And I'm going to get out a red and a green because we're thinking about positives and negatives. So we have addition, subtraction. These are opposites. So I'm going to draw an arrow pointing at each other. Add and subtract are opposite. Then we have multiply and divide. Those are also opposites. I want to introduce something that many of you may have seen, but this also might be new to you. And if it is, don't freak out. We're going to talk about it. Something you may not have seen before is this operation. We're going to start with that. Does anybody know what that would be? It's an exponent. Good, good. An exponent. We're doing something squared or to some sort of power. We'll talk more about it. For now, just write it, and we will get into it in a moment. So we're writing the opposites. I know the opposite of add is subtract. Opposite of multiply is divide. Does anybody know the opposite of the exponent or the squared here? Square root. Ooh. So that's a check mark. Looks like that with a little roof over the top of it. That is your square root. So those are opposites. And if you're worried, you may forget the names of these things, as silly as that might sound. It's not a bad idea to write down things that I'm saying, or you can always ask me to repeat if I go too quick. But we've just got add, subtract, multiply, divide. And I'm going to call this squared and square root. So I'm going to write that. Squared. And I'm going to abbreviate square here. Square root. Just because these are the probably newest operations that we're looking at today. So does anybody know what it's called when we are solving equations and we're using these opposite operations? There's a fancy word. It starts with the letter I that we use to name these pairs of opposites operations. It may not have been talked about much in your previous classes. When we're solving an equation, we're using blank operations. Anybody know? Okay, if you don't, I'll tell you.
I can't think of the name.
No, even
Right
if
there.
it's there, that's why it's always good to go over stuff.
Yes, yes. More of a hint in something. Almost. Are we not sure?
No. No, say
Almost. Inverse operations. Have you ever been taught that, or is that a brand new word?
that's a brand new word.
It's a brand new word. Okay, so we're going to write that down. These are pairs of inverse operations. So we're going to write that down, and I'm going to use this here. Inverse. Inverse just means opposite. Inverse operations. That's exactly what all of these are. And so I'm going to kind of circle this as a group. Inverse operations. They are opposite. And when we use inverse operations in an equation, this is what we're using to, quote unquote, cancel things out, if that sounds more familiar. I'm going to write that as well. Cancel things out. And then I'm going to show you an example, because right now this is just a bunch of gibberish. And when we put it in context, it should make a little more sense. Now, keep in mind also that this order that I wrote these operations in is typically the order that we use them in whenever we are solving equations. So what I'm going to do is underneath these inverse operations that we just wrote down, I'm going to give you the first example of a simple two-step equation. Example. We'll start with 5x minus, let's go with 3 equals 22. So this is an equation. I have 5x, which, what operation is happening between the 5 and the x? Does anybody know? Yes. Multiply. That means 5 times x. So 5 times x, so 5 times some number that we don't know, minus 3, equals 22. Does anybody have any idea what you might want to do first to begin solving this equation? Yes.
Put a line through the equal sign.
Ooh, that is, yes, that is a great way to start. Okay, so you're gonna visually, this part is optional, but wow, it really helps. If you draw a line over your equal sign, it's gonna help you see that I've got two sides of my equation separated by that equal sign. Yeah, there's the light bulb. It helps. And then the next thing we do is we're looking to see, is there any addition or subtraction that we need to get rid of? That's the first step. There sure is, -3. So we're using inverse operations, the opposite, and we'll do, instead of -3, we'll do +3.
+3 on the
Yes.
side on the other side.
On both sides, absolutely.
Then you cross out those two,
Uh-huh.
then you add on the other side, same thing.
Yes. So what happened is that -3 and +3 canceled out. Yes, they cancel. So we cross them out.
You bring down, once you do the math on the other side, you bring down the 5x.
Yes, we're going to bring down everything.
Equal
5x
sign. Okay.
equals, and then
25.
25. Good. 22 plus 3 is 25. And is that yellow? Can you guys see that? Okay. All right.
Then you divide by 5.
Ah, yes, yes. This is 5 times x. How do I get rid of times? Well, I divide. So we can divide by 5, and then I'll have x by itself, which is what we wanted. So divide by 5, divide by 5. Beautiful. We get x equals what? 5.
X equals 5.
Yes, very nice. Okay, so this is at one of the more basic levels, solving an equation. And what you just did is whenever we got rid of or canceled out that -3, we used inverse operations. We did the opposite. We did +3. Then when we got 5x equals 25, we used inverse operations again. We use division because that's the opposite of multiplication. And then we know that x is 5. How do we check that our answer is right? There is a way to do it.
You just plug in 5, so 5 times 5 minus 3 equals 22.
Yes, yes. The beauty of this whole process is what we just did is we found the number that we can replace x with to make this statement true. So what we're going to do is exactly what Alexis said. We're going to plug in our answer. So I'm going to show you what that means in case this is a new concept. Basically, we're taking the original equation, which is 5x minus 3 equals 22. But instead of x, we're going to use the value that we just found that is equal to x. Because if x equals 5 and this is x, can't I say that this is also 5? Because x is 5. So we're going to now plug that in instead of using x. 5 times, instead of x, times 5 minus 3 equals 22. Now, before we go through and solve that, is anybody unsure about what I just did? Did we see? Yes?
Replace the 5 with the x.
Yes, yes. We just replaced that original equation. Instead of having an x there, we put 5 because x is 5. It's
Yeah,
the
with
same
the
thing.
original answer at the bottom.
Perfect.
Okay.
And we're checking our answer. So what would I do now?
You go through the same process. Will you?
Sort of.
You would do the 5 times 5 first, then bring everything else down.
Okay. So now we're not solving an equation because
Okay,
there's
we
no
don't have no
variable.
x.
We already
Yeah.
solved. So right now we're plugging it in and then we are basically just simplifying this using the order of operations, which we'll talk a little bit about that in a minute. But I see 5 times x or 5 times 5 comes first, and that is 25. Bring down -3. Bring down equals, bring down 22. Now, and again, if this helps, you can draw that line down the middle to show that we are just working on this side. I'm just going to bring that 22 down at every step. What should I do next? Add 3 on each. You could do that. You just blew my mind, actually, because I've never tried to do it this way. Okay, so this is a cool moment. You actually did not make a mistake, because that will still work. So there's 2 things you could do here, guys.
Okay.
You could go ahead and do 25 minus 3,
Okay.
and that will give you 22.
Okay.
And that will give you what says 22 equals 22. And that's true. So we got the right answer. But something really cool that you just said is, what if we add 3 to both sides? Technically, you can do that in the equation. As long as you do the same thing on both sides, that equation is going to be true. Watch what happens. What happens? +3. Well, that cancels. +3. What comes down? 25 equals, what comes down? Guys, that's also true. It works.
Yes.
That just blew me away. That's cool. Yeah, so that works. That works. The beauty of math, and something that you're going to discover in Algebra 2 especially, is there is no one single way that is the perfect, correct way to solve a problem. There's going to be about 1 million different methods for every problem that we do in this class.
Puzzle.
It is. It's a big puzzle. And as long as you're following the right rules of all the math properties, you can do it in infinite ways. And you're going to get the right answer. Just follow the math rules and you can do it. Okay. Okay. So that is our basic example of solving an equation. We also need to discuss what happens when we have an equation like this. Let's go up a level. Here's another example. And actually, sorry guys, sometimes my brain gets ahead of itself. I'm just trying to think about, if I was looking back at my notes and I saw this problem, I might be thinking, what did I do over here? I'm going to make a note that says, plug this in to check my answer, just so that I know what I did there. Because the whole point of writing notes is for your future self to have a guide to look back at. If what you're writing makes no sense to you, there's not as much of a point of writing it. And actually, I want to backtrack. There is some sort of scientific, physiological connection when it comes to writing notes. There was a study done with college students where they would literally, like during a lecture, they would sit and scribble on their paper like this and listen to their professor. And even though they weren't writing notes, those students retained the knowledge better than the ones that didn't take notes. There is something that goes on when you write and you are taking in information. It helps you process it better. Now, I think you're going to understand it better if your notes look like this instead of scribbles. Because my goal is to give you, like I said, a guide for your future self to look back at. Because when I'm writing notes, I'm assuming that whenever I get done doing this, I'm going to forget. And I'm going to be able to look back and understand it like I'm teaching it to myself all over again. So the more directions you give yourself in your notes, like plug in to check answer, the better off you're going to be. Because it's like you're helping yourself in the future. It's what everything you do in the present does. It's you guys being here today is, you're one day closer to having your diploma. Your future self is thankful for that, just so you know. So let your future self that takes a quiz later be thankful that you wrote the note. Plug in to check answer. Here we go. Wow, I can't spell. Okay. Anyway, that was a really long-winded side note.
That was great. Love it.
Thank
Love to
you.
hear it.
Thank you. Okay, so let's go one step further. That was just a not too bad of an equation, but let's talk about one that has variables on both sides of the equal sign. Uh-oh. About 4x minus 2 equals, let's do 5 plus 3x. This one's a little bit mean, but we can do it. We can do it. So I'll give you a second to copy that down. And one of the best things you can do if you are staring at a problem and you think, I have no clue where to start, what is something that you can do to make finding that starting point easier?
Follow the order of operations.
Following the order of operations, absolutely. Which, if I'm saying order of operations and you're thinking, what does that mean? Well, there is a poster right here in front of the room. The order of operations is, if you ever heard the phrase PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. It's just the order of the way we do things to numbers, like adding, subtracting, multiplying, dividing. And just keep in mind that with equations, we're using opposite operations, inverse operations. So we're doing that in the opposite order, which we have written up here in the order. Okay, so that's a great thing to think about. Think about the order of operations. Is there something else I could do to think about this problem?
Can't you work one side and get rid of one of the x's?
Ooh, can I work one side and get rid of one of the x's? So
What I did.
You
was
are
exactly what you did above.
what I did above?
Yeah, I just, the big one, the -2, and I added, did the little line.
Uh-huh.
+2, there's a +2 over there.
Yes.
I didn't get any further than that, but.
Okay, but that's a great first step. Okay, so I'm getting lots of really good suggestions from you guys. Here's one of the things I'm going to always recommend is if you don't know where to start, draw that line through your equal sign. That is going to help your brain organize the different sides we're working with. So let's do this. Here's my line. And now we want to see how on earth am I going to get my x by itself. Somebody suggested, why don't we get rid of -2 by doing +2? Can we do that? We can. So let's do that. I'm going to add 2. Now, where it gets tricky is we need to decide now, what am I adding to on the other side? Do I add it to 5 or do I add it to 3x? To the 5. Who can tell me why?
Singled out without the exponent like.
So this -2 and this +2, these are terms with no variable, no letter, just a number. 5 is the same in that way. It has no variable, no letter. 3 has a letter, x. 3x, it's an exponent, or not an exponent, a variable, a variable. So I cannot put +2 with my 3x. It's not.
Peanut, don't kill
That's
somebody.
right.
Yeah.
Miss Sylvia's been telling me about that stuff, man. Okay, so I'm gonna cancel my 2's and we're gonna add it to the 5. We get it. Okay. So what happens next?
Bring down
Yep, bring down the 4x. Is there anything else before the equal sign?
equals.
Just the equals. Good. And then what's next?
5 + 5 is 7.
Oh, let's be careful. 5 plus 2. Yes, that is 7. That's right. 5 plus 2 is 7.
Bring down the +3.
Bring down +3x. Good. Okay. Now I have a whole new equation. If you are somebody that gets unorganized when you write, it happens. It's okay. This is where sticky notes can be so very helpful. I like at each step to think of my equation as a whole new problem. I can cover this up. And now I have 4x equals 7 plus 3x. Okay, now I'll uncover that in case anybody is still copying that last step down. But at this step, what is the next thing I can do?
Subtract this one.
We're going to subtract 3x from both sides because I got x's over here, I got x's over there. I need the x's to be on the same side of the wall. How are you doing?
Good.
Good. Good to
Sorry.
see you. You're okay.
From behind.
You are okay. We got it all on video. Okay. So minus 3x on this side, minus 3x on the other side. And what is going to happen at this step of our problem? Yes. Oh my gosh. Believe it or not, this is the end. We're done with the problem after this because look what happens. 3x minus 3x cancels. It disappears. I'll bring down my 7. Bring down equals 4x. Take away 3x. That's going to leave you with 1x. Or we could just write x. Because if there's no number in front of x, are we comfortable with knowing that there's an invisible 1 here? Or does anybody want a little explanation on that? Anybody? Basically, the number in front of the x tells you how many x's are there. If I'm looking at this, how many x's am I pointing to? 1. There's 1. If there's no number, there's 1. Okay? So if 4 minus 3 is 1, well, 1x is 7. We're done. We solved it. So, there you go. Okay, and let me pause this for just a second. All right. Do we have any questions about this? This last problem we just did before we do something else. Okay, can I show you another one? That's just a little bit trickier. We're just going to keep going up each time. So I'm going to go ahead and flip my page and call me wasteful, but I am going to start on the next clean page because my pens bleed through and it's going to bother me. Okay, so I am also going to title my page with every new one. So this is page 2 for me. And this was my day 1 notes continued. So I'm just going to write that. This is Alpha 2. Unit 1. Okay. So one more example I want to make sure we understand. What if I have a problem like this? 3 parentheses 2x plus 4 parentheses equals 6x minus 3.
You gotta distribute the.
Lewis, yes. You know this. Very nice. Okay, so I'm going to let everybody think for just a moment in case you don't know this. Think about what you might do first, and then, Lewis, if you want, after some think time, I'm going to have you help me with this one. Let me just pause it for a second while everybody see if you can solve this. Look at it. First, Lewis, I am going to still call on you. What is the first thing you thought about doing here?
Distributing the 3 times 2x,
Yes.
6x.
Okay. Now, in case you forgot, distributing is just multiplying. If you have a number outside of a quantity in parentheses, you're just multiplying everything in the parentheses. So, like you said, 3 times 2x is 6x.
3 times 4 plus 12.
Yes, 3 times 4 gives us the plus 12. And I'll bring down equals, bring down 6x minus 3.
I added the 3 to both sides.
Okay, that's a correct next step to take. That's a great step. So, Lewis added 3 to both sides, which we can do. Let's add 3 over here. Where else would I add 3? To the 12. Again, if it helps you to draw the line, do that. Draw the line. So my 3's will cancel. And what comes down next? 6x. Good. Plus 15 equals 6x. Okay. Now what?
Like,
Divide.
What are you going to divide?
Your 6x's.
My 6x's?
I thought you would
Would you
subtract.
subtract 15?
You could, but then you're left with, you either have 6x plus 15 equals 6x, or you're going to have 6x equals 6x minus 15. Does that not help us?
No.
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 You could also, here's another thing that Alexis just said. What if I combine my x's? Like I do minus 6x. Let's try that. Minus 6x. Okay. So
Cancel out.
that would cancel. And then I have 15 equals, and well, if these cancel, I can't just say 15 equals nothing. What would this really be?
Nothing equals X.
Not x, because if I have 6 x's and then I take all 6 x's away, what am I left with?
0.
0. 0. So let's ask ourselves, 15 equals 0. Is this true?
No.
No. So this is a case that you may run across in Algebra 2, because problems like this exist. If you come to a point in your equation where you have a number equals another number and it's not true, this is what just happened. Your answer is that there is no solution.
Isn't it 0 with like a line through it?
Yes, no solution, or like that. This is your answer because that is not true. So I'm going to write here, this is not true. And what no solution means is I can plug any number I want in for x in this problem. Doesn't matter what number I pick, it will never work. I could pick negative 20 million. I could pick positive 2, 3, 4, 5, 10 million, whatever I pick. No number will be a solution for this equation. There is no solution. That stresses a lot of people out because they think, what if I make a wrong step and it's not working? We're going to get really good at this. We're going to do a lot of practice. Yes.
How do you know what order you do like the addition and subtraction with the 2 for 12 and negative 3?
With the 12 and negative 3, excellent question. It doesn't matter. You can do it either way. So I can show you, if you wanted, over to the side, or I'll do it on a sticky note so I don't make my notes too crazy. We're at the step now where we have 6x plus 12 equals 6x minus 3. Maybe instead of doing plus 3, you decide to do minus 12. I'll do minus 12. If I do that, I'll get what we talked about earlier, 6x equals 6x minus 15. You'll still get no solution. You can do it in either order. This time you'll get 0 equals negative 15, and it won't matter. There's no solution. No solution. But knowing that we need to distribute first is kind of the main point of this. And also knowing that sometimes there's not an answer, and that means your answer is that there's no solution. Sometimes it doesn't work. Okay, and does that answer your question, Tyler? Okay, good. Good, good, good. All right. All right. Now, we have done quite a bit in the past, and we just did 3 together, examples of just solving equations. Let's also, just for the sake of us ending on a one that works, let's do one more before I teach you what Unit 1 will be all about. We're still kind of in the review stages. And before I go on, does anyone need more time to write this? I don't want to move too fast. Okay. So one last example. And if you don't have a calculator with you, you might want one for this because I'm going to make the numbers up on the spot and you'll probably get a decimal. Let's go with 4. This one will not give you no solution, but I bet it might give you a decimal. It might not. Can't work it out in my head that fast. So I have 4 parentheses, 2x minus 1, close the parentheses. That's equal 7x plus 3. What should I do first?
You're 4 times 2.
Yes. 4 times 2x, 4 times minus 1. We're going to distribute first. And remember, if we distribute, we're just multiplying. This is multiplying. And if this is more of an introduction to this stuff than it is a review, not a bad idea to maybe write multiply. So you'll remember later. So what is 4 times 2x? 8x. Good. 4 times that minus 1. -4 or -4. Good. And then what do I do? Equals, just bringing it down, 7x plus 3. Just bring everything else down. Okay. So now at this step, we have lots of options. Whenever we have longer equations, we can do a lot of different things. I want to hear as many options as we can think of. What is one thing we could do?
Subtract 7x from both sides.
Okay, we could subtract 7x from both sides. What else could we do?
Subtract 3,
You could subtract 3 from both sides. Perfect. What else could you do?
add 4,
You could add 4 to both sides. What else could you do? There's one more thing.
You can add the 8x.
You could subtract 8x from both sides. You can do any of these 4 options. It's going to give you the same answer as long as you follow the rules of solving equations. So, I feel like the way my brain works, I always am kind of looking at this side of the equation first because that's the way we read from left to right. And I'm kind of thinking I have a -4. I'm going to add 4. If you didn't add 4, you're still going to get the same answer, so it's okay. I'm going to write +4. If I'm adding 4 here, where else should I add 4? Under the 3. Good. So +4 plus 4. Those 4s will cancel. And let's bring everything down. What comes down? 8x equals 7x plus 7. Good. 8x equals 7x plus 7. We're almost done. I didn't give you a decimal. Okay. Now what should we do?
Subtract 7x.
Yes. Yes, subtract 7x from both sides because now all that's left is to get my like terms together, get my x's on the same side. -7x, -7x. And those cancel. What's 8x minus 7x?
Okay.
It's x. Good.
3 plus 7.
X equals technically plus 7, but do I need that plus anymore?
No.
No, that plus just means I'm adding it to whatever is on this side of the equation. Since everything else canceled on this side of the equation, all I have left is 7. X equals 7. That's your answer. There you go. Okay, we ended on a note that is not no solution. So we'll do that. All right. So this is the end of our just reviewing basic solving equations. And again, I'll let that kind of sink in for a second. But what we're going to talk today about is the introduction of systems of equations. You're going to learn how to solve 2 equations at the same time. That sounds crazy. You can do it. We're not going to go right into something crazy, though. I'm going to go one step at a time, little bits by a time. And at any point that we are taking notes, going through things, tell me if you don't understand what I wrote or what I said. Class time is the best time to be asking questions. Does anyone still need to see this, or can I turn my page? Okay. I'm going to turn my page, and I'm just going to title this page 3. Day 1 notes continued. Two. Unit 1. So we're going to use all of those things that we just talked about, but now we're going to put them in context of, we'll title this systems of equations. Main difference in solving one equation versus solving a system is that instead of just solving for x, for one variable, now we need to solve for x and y. There's 2 variables. So we'll start with something not so scary. We're going to start with a system of 2 equations. The first equation will be 5x plus 2y equals -13. And your second equation will be a little bit more simple. I'm just going to give you, it'll be y equals -4. So this is a wonderful system because one of our variables is already solved for, isn't it? I'm trying to solve for x and I'm trying to solve for y. What variable do I already know?
2y.
I know y. And yes, we can use that in the 2y here in just a second. But I know that y is equal to -4 because it was part of the equations that were given to you. So y is -4. I'm done with that. I'm going to circle it because I know that that's one of my values. Done. So how can I use this to help me solve for x?
You can plug it in for y.
Yes, I can plug it in for y. We're going to get this equation so that there's only an x variable, and we can get rid of the y because I know that y is -4. So instead of y, let's plug in -4 for y. So I'm going to rewrite that original equation. But instead of y, we're going to put -4. So I'll bring everything down. 5x plus 2 instead of y, -4. Equals, don't forget the rest of the problem, equals -13. Yes. Yes. Instead of y, we're writing -4. Yes. So now I have an equation with just one variable, which we can solve. Something that is a good note to remember, and I will repeat this a million times this term. As soon as you plug in a number for a variable, your next step is usually going to be to distribute or to multiply. Because I can't keep my problem like this. What do I do here? 2 times, not just 4, -4. 2, you're okay. 2 times -4. What is that? -8. So I'm going to cross off my 2 and my -4 because I don't want to bring that down on accident. I'm going to write -8 instead. And I'm going to write here, distribute. Just as a side note. So,
Pull everything down and then solve it like normal.
yes, let's pull everything down and then solve like normal. So what comes down? 5x.
Keep the minus because the 8 is negative.
Yes. So do I need to bring down that plus?
Nope.
No, I don't, because if I do plus -8, that's the same thing as what I've got here. 5x, we can think of it as -8. Okay, 5x minus 8 equals -13. Good.
Add 8 to both sides.
Yes, add 8 to both sides. Okay, you can draw your line if that is something that helps you do it. So we'll add 8. Now be very careful because we're adding numbers that don't have the same sign. You're not just doing 13 plus 8. -13 plus 8.
Positive and a negative and
This is where I'm going to tell you guys, it's okay if you don't have all of these rules memorized for adding and subtracting negatives and positives. I want you to rely on your calculators. We're going to be using our calculators a lot because we're going to be doing more complex things. And if you get really good at using your calculator, those complex things will be a little easier to do. So as a reminder or an introduction, if you have never used one of these calculators before, to type in a negative number at the bottom of your calculator, there is a negative sign in parentheses. I'm talking about the yellow calculators that we have in this room. If you don't have one at your desk yet, they are over there if you would like to get one. If not, we're almost done today. It's not the end of the world if you don't have one today. I'll make sure we all have them tomorrow, but I'll wait a second if anybody wants to get one. But at the bottom of that yellow calculator, this minus with parentheses, you're going to push that. And now I have, you can't even see it, but there is a negative on my calculator. So then I'll type 13. -13 plus 8 equals -5. And I love these calculators because with the smaller ones, if you don't type your problem in right, there's no way to know. On these calculators, you can see what you typed. So if you made a mistake, you'll know what you did wrong. So we got -5. I'm going to bring that down. So -13 plus 8, we got -5 equals, bring down 5x.
okay.
You got it, Diane. That's what we're going to do next. We just divide by 5 and we'll have our answer. Perfect. Divide by 5. Divide by 5. And we get x equals what? Mhm. Yes, -5 divided by +5 is -1. Perfect. That's your answer.
Amen. Hallelujah.
Yes, yes. Now, there is one last step whenever we're solving for two variables, because I want to make sure that we know which one is X and which one is Y. I don't want you to just say, okay, there's my answers. I don't want to have to dig for them. And this will be relevant when we start graphing and things. Have any of you guys heard of a coordinate?
Yeah.
A coordinate, an ordered pair, a point on a graph.
Yep.
So this is an example of one. I'm going to write this down. There's in parentheses and a comma. There's an X value, a number for X, and then a Y value, a number for Y. Hi, Angela. So what you're going to do is you're going to put the answers you found in this coordinate, and I will write that word down. coordinate. Coordinate. That's what this is. So if I am putting my answers into a coordinate, remember X comes first, always. Y comes second. What is the first number I will write? -1. That's my X value. What's my Y value? -4. We found that at the beginning. -1, -4. That is your answer. And then you circle it because you're done. There you go. There's your answer. So systems of equations, especially whenever you've already got one variable solved for, they're not too tricky. You're just adding an extra step of plugging a number in. Oh, let me give you one to try by yourself. I'll see if y'all can try this. You're going to follow the same steps we just did, but with different numbers. You try this one on your own. I'm going to give you two equations. The first one is y equals 5. The second equation is -4x minus 2y equals -10. Follow the steps that we just did above and solve for x and y. I'll pause my recording and let you guys try that on your own. If you get stuck, don't be afraid to ask for help, and don't be afraid to talk to each other and help each other out as well. And then we'll go over this in just a minute. Yeah, I'm gonna let you go. All right, so who can tell me what should I do first?
Plug in your five with the Y.
Yes, I see that y is already solved for. Y equals 5. So let's plug that in to my original problem. I have -4x. We'll bring it all down. -4x minus 2 instead of y, 5 equals -10. What do I do now?
You distribute your 2 and 5.
Good. Distribute my 2 and 5. Being careful with my signs. What happens here? Yeah. Perfect. -2 times 5 is -10. And then we'll bring everything down again. -4x minus 10 equals -10. What do I do now?
Add your 10 to the other side.
-10.
Add 10 on both sides. That cancels. add 10. Now, I know that we just said minus 10 and plus 10 cancel. If this is the only thing on the other side of my equation, on this side, am I going to cancel this and not write anything?
No.
No, negative 10 plus 10 is 0. When we cancel something, it means it equals 0, okay? We're just not writing that 0 because we don't need it. There's something else to bring down. There's nothing else to bring down over here, so we are going to write that 0. And we'll bring down negative 4x. What's my last step?
Are you done?
Divide by negative 4 to get rid of it. And x equals 0 divided by negative 4 is 0. So look at that. X is 0, y is 5. So as a coordinate, what number comes first? 0. X comes first. And then 5. That's your y. Perfect. There you go. Okay, so that is our little introduction to systems of equations. Please know that if you felt good today, that is wonderful. That doesn't mean you can skip the rest of the week. We are going to be moving forward to more things every single day. We start a little slow, but it does get a little faster as we go. So stay caught up. Please keep coming. I love to see all your faces. That is all we're doing today. Please know your exit ticket for today is to turn in that classroom agreement signature page. If you have already done that, you are free to go. This is due by Friday. Due by Friday. You can leave them at your table. You can put them back on the shelf. Up to you. Other students will probably use them anyway. Okay. You guys have a nice day.
It's like